which is which. Queen is the yellow one. Huey Lewis is orangey. There we go. So looking at that, you can tell in the order in which these things will be printed. The start indicates the start of the program. The stop indicates the stop of the program. So when we invoke Joan Jett, it prints I love rock and roll and then returns. Then we invoke Queen. Execution jumps to the Queen function, which prints crazy little thing called love and then returns. Then we invoke Huey. It prints the heart of rock and roll, returns. And then we call Joan Jett one more time, prints I love rock and roll, and return. So that is how we flowchart functions. These are predefined processes or functions. In our flowcharts, we're going to denote that they are predefined processes with the DEF keyword. That's just our convention in this class. That's not strictly true because other languages define functions in different ways, but that's a good enough way of doing it. And the end of every function will have a return statement. If the function does not return a value, if it is a void function, we will just put return with nothing after it. If it does return a value, then we'll put return and then followed by whatever it's calculated. The sum of a series of numbers or whatever data is being returned. I believe our other function had to do with turtles. Let's go take a look at. Yes, sir.
How do I make the line go behind it or run through?
Oh, select the line and do send to back. Yeah. If you tried to do that trick where you drew one line and then wanted it to go behind all the others, you just click the line, right-click it, and do send to back. That way you can get it behind all the other stuff really fast. So I'm going to go in here. I'm going to write a little function. Kind of just tuck this away over here. Yes, sir.
Are you recording?
Yes. Thank you for asking, because 5 minutes ago I was not. Here we go. So I'm going to define a function called double me that takes an argument and returns 2 times that value. And then another function called triple me. These are fruitful functions. They return values. They're not void functions. So after the word return, we put what they are returning. So now let's get a number that we can then double and then triple. We are no longer inside those functions, so we are no longer indented. Print, enter a number, in for number is equal to input, and then let's convert that either to an int or a float. Do we want to allow them to do decimals? Sure, why not? So n is equal to float, parentheses n. And I'm going to put little comments. Get number, convert it. So now I need to pick two variable names. One for the number that's been doubled and one for the number that's been tripled. So I think I'm going to call this one double n is equal to double me, and I'm going to pass in n like that. I mean, I could have just called it X or Fred or Barney or whatever. And then triple n is equal to triple me. Print doubled is double n. I'm not really digging those long variable names, but at least they do convey some meaning. I'm going to save this in a file called dubtrip, D-O-U-B-T-R-I-P. I type in a 20. It says doubled is 40 and tripled is 60. So here's a question for y'all. What if I did this? N is equal to 10. N is equal to double me n. N is equal to triple me n. And then print n. What is it going to print out? So it's actually like a logic problem or something. I want us to actually puzzle it out. We're going to pass n into the double me function, and then we're going to store the return value of that back into the n variable. And then we're going to do the same thing. We're passing n into the triple me function, and then storing the result back into n. It's going to double n, store back into n, so n will equal 20 here. And then what is n going to equal after this line executes? 60, yeah. So you see what happened. N pops up here, the result is equal to 2 times that, we return it is equal to 20, so 20 gets written into the n variable. Then we invoke it again, triple me, it goes up here, that number is 20, the result is 3 times that number, which is 60, which gets returned and stored back into the n variable so we can print it out. You can use the return value from one function call as the input to another function call. Change that back to 10. This would print the same thing that this print does. Let me change the order of these though. The reason this prints 60 is that the first thing that happens is double me is called with 10 as its argument. And what does double me with 10 return? 20, which is then fed in as input to the triple me function. and triple me 20 is 60. So when that returns, that gets passed in as input into the print function. So sometimes you'll see people nest calls like that. You'll see people do this, and it's okay to do this, but I tend to separate the steps. But you could do this. Age is equal to int parentheses input parentheses enter your age. What this does is you have to figure out which is going to be invoked first. So you keep trailing it down inside the parentheses until you find the innermost one. And that's the innermost one, input enter age. So that gets invoked, it lets them type something in and returns it. And then whatever it returns is passed in as input to the int function, which converts it to an integer. Now that's converted to an int so that we can use it in math, and that's stored in age. This one statement does the same thing as this. Print, enter your age. Age is equal to, go away. Age is equal to input. And then age is equal to int age. So this one line serves the purpose of these three lines. And our goal is to not cram as many lines in as possible or to write the shortest code. But if you find this easy to read, feel free to go ahead and do that. Otherwise, do it like this. Or at least put the string, enter your age, inside the input statement.
So you don't have to put the return function for that to happen, though, now.
Right, because I didn't write the input function and I didn't write the int function. They're provided for us. If we could find the source code for them, if we went digging in the Python source code, we'd see that input does return. It has the word return in it, but we can't see it. Pardon me? Somebody? Okay. Anybody need help correcting typos? Real good? You can also define functions right inside the shell, but of course you can't save them once you've done that. I'm going to pop open the shell. DEF double me in colon result is equal to 2 times in, return result, and then I hit a blank line to stop that. Now if I call double me and I pass in 10, it returns a 20. If I call double me 20, it returns a 40, and so on. So I defined that function right in the shell. Is there any real point to that? No, it's just to show you that whatever you're doing over here, you can also do over here. But the problem is if I made a typo in this, it'd be much more difficult to correct it than if I do it over here. So here's a warning. Sometimes when people are writing programs and they kind of forget the syntax, they'll do things like this. Input, I don't know why it keeps trying to tab that when I don't want you tabbed. It'll say input equals hello. Something like that. Don't type that. That's wrong. It didn't give me an error though. What's wrong with that is that input is a function. And here we're erasing that function and we are replacing it with a word. So now input no longer works. I can't do x is equal to input enter age. That is broken. The reason why is that we took what was a function and we erased it and we replaced it with this string. So if you're typing code and it highlights the word as purple or blue or something, you don't want to use that as a variable name. Another thing that people tend to start doing is they want to put equal signs everywhere. Print equals enter age. No. Print is a function. It's not a variable. A variable holds data. A print is a command. So both input and command and both print and input are commands, are functions that we want it to do. So you use parentheses with them rather than using equal statements. Now that this is all messed up, I'll never be able to get it to work again until I close that shell. So if I try to print hi, no. Because I erased what print was. Print is no longer a function, so that fails. But I'm just going to close the shell and relaunch it with the run menu, and now I can print stuff again. Okay, so this double me and this triple me. Let's do those as well. So I'm going to scroll down to a different part of my flowchart. And I'm going to have three functions. One is just start, where our code normally starts. And then I'm going to define another one called double me. DEF double me. That takes a variable called x. And one called triple me. Now what did double me do? It did two math things. Well, one math thing. It calculated a result. Result is equal to 2 times x. And then it returned that. So triple me is going to look very similar. Goes to a math box where result is equal to 3 times the parameter passed in. And now let's just do the code that did n is equal to 10, then we doubled it and we tripled it. So under start, we're going to do a math block that says n is equal to 10. Underneath that, we're going to call our double me function. Now when you call a function, you don't use the math block, but you use a similar one, which is the predefined process block, which is like the math block, except it's got the 2 bars on it. N is equal to double me n. And then another one that says n is equal to triple me n. And then we print that out. And then since the program is done, we issue a stop. Want to be fancy schmancy, we could colorize these the same way we did on the other one. Make that light blue.
that yellow. Is this necessary? Absolutely not. But it does make it reach out and grab your eyes. So the next thing I'm going to do is I'm going to write some code that has two functions in it, and I'm going to want you to draw the flowchart for it. These need to be in boxes with the two bars. If you put something in the wrong shape, it's not a disaster. You don't have to delete it and redraw it. Like suppose I wanted this in a tilted box. You just right click on it and do change shape. I'm not going to change it because that's the correct shape, but you need to right click on it to change shape. Just select one of them, not all three. Select that one, right click on it, change shape. Same to that one. Sure. Well, that was a syntax error, but that's not a problem. One, two, three, two, one. Open my mistake. The problem isn't actually on this line. It's that this one did not have that closing parentheses. And that was my mistake, so I'll go over there and I'll show it. Alright guys, for y'all who were typing along with the code, when I added that age is equal to input stuff, I had a syntax error, so it would not have run. Let me show you the syntax error. No, wait a minute. Oh. Yeah. Okay. The syntax error is actually on this one that I said would print 60. And what is wrong with it? If you can eyeball this and spot the error, the problem is that I have more open parentheses than I have closed one because they have to match. Here's a pair. Here's a pair. But this open parentheses doesn't have a closed parentheses to match. So if you were trying to get this code to work and you did not, it's because I forgot to do that. I needed 3 closing parentheses because I had 3 opening parentheses. Let me just make sure this works. Okay. So the program got rather dumb towards the end. You know, we're telling them to enter age, and then we tell them to enter the age again. The real point of the program was this point, these 4 lines, and then the double me and the triple me. That's the stuff that we actually just flowcharted. We flowcharted the double me and the triple me, and then we flowcharted this stuff. So this program is going to have 2 functions called square and square root. So square is going to take a number. Result is going to be n to the power of 2. And then we're going to make another one called square root. Wait, that's bad syntax. Not return is equal to. Result is equal to n to the power of 2, and then return result. And in the square root, we're going to also use the exponent function. The result is equal to n star star 0.5. Raising something to the 1/2 power is actually the same as taking the square root of it. Without running this, what should x equal theoretically? We take the square root of it and then we square it. So we'd like the output to be 10. Yeah. It probably won't be 10 exactly because of rounding errors. Sure. Very good point. But this would be a bad way to take the absolute value of something because we're going to get a rounding error, I believe, when we're done. So I'm going to call, oh, you're right. We would have to square it first. Okay. So I'm going to save this as a program called just SQ. And run it. And while I would like for it to print 10, instead I get a syntax error because I forgot a colon. Every time you start indenting, you have to have a colon before that. I forgot a colon there. So both of our DEF lines have to have colons at the end of them. All right. So it turns out that if you take the square root of 10 and then you square it again, it's not back to 10. It's equal to 10.00002. So that's a rounding error. That's just because floating point math is not exact. Integer math is exact. If you double something and then you take half of it, you get the original number. But floating point math, math that uses decimal points, is not exact inside of a computer. You get rounding errors. Go ahead and flowchart this program once you get it running to your satisfaction.
Do you want us to switch it to the square first and then third?
Yeah, let's do that.
Or, well, I'm talking about like in the flowchart.
Well, you can put them in any order you like in the flowchart.
You want us to put it in the same flowchart or make a new one?
Doesn't matter. Just make a new one. Yeah, make it nice and pretty. Yeah, notice that when we squared it first and then we took the square root, we didn't get our rounding error. So I'm going to move it back the other way because I think the rounding error is interesting. So yeah, go back into Lucidchart and do a new spreadsheet, not a spreadsheet, new diagram, and go ahead and flowchart this. take some of y'all not very long to do this. I'm going to tuck this code to the side and draw another flow chart that I would like for you to turn into code. And so that's the two things that I want y'all to turn in. It's a flow chart for this one, and then the code for the flow chart I'm about to draw. This is annoying. When you do file new, you have to look for a long time to find the flow chart. There, blank diagram will probably do it. Okay. So here's the program I'd like for you to write. Just call it invert.py. Guess I'll put some little label there.
Should integer be invert?
You need to say reciprocal now.
I never called it. And reciprocal would be a better term for it. You're right. I never actually called the function. Let's insert a call to the function right there. And this should be an input statement. Jeez. There we go. So the fix for that error is that we had X there, that was not correct, so that had to go bye-bye. So we will upload our last flowchart and our last script into the in-class Dropbox, and then we're done for the day.